Hey guys, this is a lesson on angle theorems for triangles. I think what would be really important is to, instead of going directly into this, is talk about how straight angles or straight lines, some people call it straight lines, and triangles have something in common. If you recall, there's an activity, especially in our book, that we use, but I've seen this activity in other places as well, where you take you draw a triangle in a sheet of paper, you cut it out, and then when you cut it out, you could take those three corners, those three vertexes, and tear them off, just like that. And then what you do is you put them next to each other and see what kind of angle it creates. So if I were to try to create, let's see if I can do it. Easier said than done at times. Alright, here we go. Oops. my big fat fingers, I have a hard problem here. Okay. Here we go. Alright, there we go. If you can see, it creates a straight line. A straight line, or a straight angle, is 180 degrees. Okay? A triangle, any triangle that you have, is 180 degrees. So, for example, using this one that we just had here, well, let me use a different one, just so I can give you an example here. Let's say I've got a right angle, just make something a little bit simpler here. Let's say I have a right angle, and it's a scaling, or I should say right angle, but all the sides are different. Okay, this would be 90-degree angle. Well, these two angles are probably going to be different, more than likely, because this side's different than this side. Okay, so let's just say, for just as an example, let's say this is 65 degrees. Okay, and I didn't know what this was. But what you could simply do is just add what you know, add them together, and subtract it from 180. Because 180 degrees is going to be the total amount of degrees in a triangle. Now there's actually a formula for how to find out how much each interior angle is worth from regular polygons, and we're not going to talk about that now. But just know that a triangle is 180 degrees. So what you're going to do is you're going to add them up. 155. Alright, subtract that from 180, and you should get 25 degrees. That's what's left over. That means that x, this has to be 25 degrees right here. Now that leads us into really the subject of this lesson here. How do we take what we've learned in terms of transversals and apply that along with what I just talked about, with straight lines and triangles being 180 degrees. If you think about it, 4 and 15 combined, if you were to add those together, add three of those angles together, it creates a straight line, right? Which is this straight line, B. So this angle plus this angle plus this angle creates 180 degrees. Okay? Also, we just talked about how we took a triangle, we broke up the three vertexes, put them side by side, and we saw that it equaled 180 degrees. So we know that all the three angles inside of a triangle equal 180 degrees. A straight line equals 180 degrees. Now there's also a relationship between those two, saying the fact that 4, okay, if you recall, remember transversals? Well, if we ignore this transversal here, for example, let's just focus on B and A, and focus on this transversal here, the solid one right here. Okay? 1 and 5, let's see, how do I explain this? 1 and 5 creates this angle here, right? If I were to combine 1 and 5, that's this angle right here. Okay, does everybody see that? Hopefully. That is here as well. So that angle is also here too as well. So if you think about it, 2 is also would be up here as well. So if I put 2 up here, that's the same angle. So 1, 2, and 5 creates a straight line, correct? So that's also 180 degrees. So, so if you think about it, right here on let's go right here. So 5 and 3. 5 and 3. If you look at this transversal here, 5 and 3 also have the same measurements because they're what we call alternative interior angles. Okay, they're inside the parallel lines. They're alternate sides, inside interior angles. They're equal to each other. This equals to 1 and 4. So if you combine 1 and 4 together, you get this right here. Right? This is 1 and 4. 1 and 4. That's what creates this side. So I had a couple questions I asked. I said, okay, is 4 and 2 equal to each other? Well, yes, they are, because these are vertical angles. Yes. They are. I don't know why I put a Y there. Yes. They are vertical angles. They're equal to each other. Vertical angles. Okay. Is 5 and 3 equal to each other? Yes. They are alternate interior angles. Okay, and this is from our previous lesson on transversals. So 5 and 3 is equal to each other. 1 and 4 is equal to here. Now, because we had this transversal here, that kind of cuts up this angle right here. This large obtuse angle is cut up with 2 little angles right here. That's why I had to put 1 and 4 here. Hopefully that doesn't confuse you. I know that can cause a little bit of confusion there. So with that in mind, let's do a couple examples. Okay, the easiest of the ones that I have here are what we just talked about earlier, that all 3 angles in a triangle are 180 degrees. So you add up what you know, you add up what you have, and you subtract that from 180, and you get the missing length, right? You get the missing piece, which in this case is 53 degrees. So angle K has got to be 53 degrees. Okay? Very similar to what you see up here on this one right here. Same concept. You add up what you know, combine those 2 together, and what you're going to do is take that away from 180. And you notice this is also 90 degrees. So that's going to be a right triangle right here. So this has to be a right triangle. Okay? Now, where this gets a little difficult is in your other example. There's another example in your book that it's just like this. Okay? And basically, what's going on is, so you have to kind of think a little bit outside the box with me for a second. We don't know. We know that this is 146, right? But we don't know what this is. We do know that a straight line is 180 degrees. So if I subtract this from 180, I should get 34 degrees. And that's helpful because if I know this is 34 degrees right here, I can go and possibly add up all 3 angles together and set that equal to 180 as well, because I know that the sum of all 3 angles in a triangle equal 180 degrees as well. So I add them up. So I add up 5y plus 3, add that to 4y plus 8, add that to 34 that we just found, and we're going to set this equal to 180. Now, how do we solve this? Well, we have to combine like terms. So 5y and 4y is 9y. 3 plus 8 is 11. 11 plus 34 is 45. And set that equal to 180. And this is basically just a 2-step equation. Alright? And for fear of running out of time and paper, I'm going to bend this, kind of just go around a little bit. Give myself some extra room right here. So we know a two-step equation is to subtract. We do the opposite of what's being done to the variable, right? We're going backwards in the order of operations. We're subtracting 45 from both sides. We've got 135 here, and then 9y here. And then we're going to divide both sides by 9 to find out what y is. And so that's going to be 15. So if y is 15, which is helpful, it still doesn't really solve everything. It helps us solve, gets closer, but I still got to plug it back in here, right? If y is 15, it's going to be plugged back in here into those two variables. So 5 times 15 is 75. 75 plus 3 is 78. So this has got to be 78 degrees. 4 times 15 is 60. 60 plus 8 is 68 degrees. So that means this angle, so angle N is 68 degrees, angle M is 78 degrees, and angle P, what we just found out earlier, was 34 degrees. If you were to add those all up, they should equal 180. Okay, if you want to double check that, go right ahead. But they should equal 180. And that's how you do, that's how that's related. How the exterior angle here, this is what we call an exterior angle, is related to the sum of these two. Okay? So that's one way to do it. The other way to do it was to add these two together, 9y plus 11, add those two together here, and set that equal to 146. And you'll actually see that you'll come up with the same thing as well. That's another way. I basically showed it to you in a roundabout way, just a different way. So this exterior angle, 146, equals to the sum of the other two angles inside the triangle. And that's kind of a hard concept to understand. Again, if that confuses you, don't worry about it. Go back to this and go, okay, if this is 146, that means this has to be 34 degrees because a straight angle or a straight line is 180 degrees. Add up what you know, set that equal to 180, solve for y, we got 15 degrees, plug it back in here, plug it back in here, figure out what those angles are, and then you're done. All three of those angles, though, if we're to add them all up, we should get 180 degrees, because the triangle has 180 degrees inside. That's the sum of the triangle, of the interior angles of the triangle. Alright guys, God bless. Hopefully, if you have any questions, I'll catch you on Zoom. Other than that, take care. See you later. Bye-bye.